Okay, it's Wednesday, May the 13th, and we're here to work on structural formulas for our Northern New Mexico College introductory chemistry class. Okay, so we had a chance to wet our beak last week, or last class, with structural formulas. And remember, they're just an alternative to Lewis electron dot structures. Okay. One of the big differences here is we do not concern ourselves with non-bonding pairs of electrons. All right, those are generally explicitly shown in Lewis electron dot structures, but not in structural formulas. In addition, we use a line segment to represent a pair of bonding electrons. So a double bond, bond order 2, would be two line segments. A triple bond would be, bond order 3 would be 3 line segments. So we're going to start, and again, I emailed you this structural formulas 001, so we're going to go over that. And I'm going to be honest with you, it takes some practice to get good at these. All right, so I'm going to do 2 different assignments here, and well, I'm going to write them on the board up here. But if you printed them out, then you have them there, and you can just write on your paper. Okay, so let's take a look at this one. Okay, so we have difluorine monoxide. All right, so now we want to take advantage of this knowledge that we know that fluorine is only going to make 1 bond. Oxygen can make 2 bonds. Again, you get the number of bonds, you put your finger on the element on the periodic table, count to the nearest inert gas. Fluorine's 1 away from neon, so 1 bond. Oxygen 2 away from neon, 2 bonds. So the question is, how are the atoms connected? Are they like this? Are they like this? Or are they like this? Right, now this one makes the most sense, right? Because here, fluorine, here, this central fluorine is making 2 bonds, which it can't do. Here we have each of the fluorines also making 2 bonds. So this structure, we're going to put the oxygen in the middle and flanked on either side by the fluorines. There it is, we're done. There it is, we're done. Again, you should go back and check, does every atom obey the octet rule? And we said that we can answer that by simply checking that each atom has the appropriate number of bonds. We're not going to count electrons here as we do in Lewis electron dot structures. We're just going to check and make sure that each atom has the proper number of bonds. If that is true, then the structure should be correct. Right? Oxygen needs to make 2 bonds, fluorines need to make 1. This structure is correct. Right? This structure is correct. Okay? Any questions or comments? I'm just going to forge ahead since nobody ever asks or anything or makes a comment. But if you have one, as you well know, just speak up. So let's look at the next one. Hydrogen peroxide. Right? Hydrogen peroxide. So this is used as a disinfectant if you get a scrape or a cut. Also used to bleach your hair, platinum blonde. Okay, now, we know hydrogen can only make 1 bond. Okay, a big part of this in these very small ones is figuring out how are the atoms connected together. Hydrogen can only make 1 bond, so the hydrogens are going to have to be on the ends of the molecule. Oxygen can make 2 bonds. So we're going to go H, O, O, H. H, O, O, H. All right? And we should have that functional group listing out also that I emailed last class. All right? Because we're going to want to identify functional groups here. And we don't, you might think this is an alcohol and this is an alcohol, but generally we don't consider the OH groups in hydrogen peroxide to be alcohol groups, right? Generally, it has to be bonded to a carbon atom for this to be an alcohol. Okay, so let's take a look at the next one. We're probably going to finish pretty early here. I'll be browsing around for something to do towards the end of class here. All right, but they're going to get a little harder. All right, so here we go. Here we have NHCl, CH2, OH. So again, we should ask, do we have any functional groups? Well, this looks like it's probably going to be an alcohol group. It looks like it's probably going to be an alcohol group. This is not an amine group. Amine group is NH2, right? So this is not an amine group, right? CH2, we should know what that's going to look like. We went over that last class. So I'm going to begin with the nitrogen, and the hydrogen and the chlorine should be attached to it. Right? So I'm going to put a check mark there. And it's wise to put a check mark when you have one of these long molecules so you know where you're at. Quite often students will turn it in with the wrong number of carbons. Right? Now, I know that nitrogen has to make 3 bonds. So it's going to have an open-ended bond there. An open-ended bond. We're generally going to grow these molecules from left to right across the board. Well, so now the nitrogen can bond to this CH2. And the hydrogens can each only make 1 bond, so they can never be part.
One on top and one on bottom, right?
Yes, 1 on the top and 1 on the bottom. Very good. Remember, anytime you see this CH2, and you're going to see this in a lot of these problems, you should know automatically, top and bottom. All right? And then carbon has to have 4 bonds, so there's an open-ended bond here. And that allows us to put the alcohol in, right? So that takes us to the end of the molecule. Right, now, we're going to go back and check. Does every atom have the correct number of bonds? Nitrogen should have 3. 1, 2, 3. Hydrogen should have 1. 1 on that hydrogen, 1 on that hydrogen, 1 on that hydrogen. Chlorine is a halogen. It should only make 1 bond. Right, carbon should make 4. 1, 2, 3, 4. And oxygen, we're done with this problem. Okay, again, on the assignment, if I remember correctly, so I have different versions of these assignments. Some of them ask you to label the functional groups, some do not. I'm going to want you to do it whether it says it or not. Okay, any question or comment here? Any question or comment? Okay, we'll move on to the next one.
That's what I mean.
All right, so the next one. Okay, so we're going to have NH2, CHBr, and CO2H.
So there's an amine and a carboxylic acid, right?
An amine group here and a carboxylic acid here. So we could think of this as an amino acid. It's got an amine group at one end and a carboxylic acid at the other. Very good. Okay, and this guy here, CHBr, remember that bromine can only make 1 bond. It can only make 1 bond. So CHBr is going to look just like CH2. It's going to look just like CH2. All right, so let's proceed with this. Well, an amine group, I know what that looks like. Hydrogens can only make 1 bond. And then there's an open-ended bond. The amine group itself can only make 1 more bond. So I'm going to put a check mark there, or to the NH2. And then, again, the CHBr is going to look just like CH2. And again, that's because the halogen, bromine, can only make 1 bond, just like a hydrogen can only make 1 bond. But this will look just like CH2. So I'm going to go CHBr, and then the carbon has an open-ended 4th bond. That brings me to here. Now, before anybody asks, does it make a difference whether I put the bromine at the top or the bottom? Actually, it does not. That was one thing I wanted to do with the dry lab for this, with our models. So I wanted you to build models of all these structures, and you would have seen that in the models. Okay? If I remember, I'll talk a little bit more about this at the end. Okay, so that brings us to here. Now we have an open-ended bond. CO2H, that's that carboxylic acid, two oxygens back to back, bonded to a carbon and a hydrogen. Right, so that's our carboxylic acid or organic acids, as we sometimes call it. And it can only make one bond. Well, there it is. It's going to bond to this carbon here. So C double bond O, O, H. Okay, there we go. Now we're going to go back and we're going to check. Does every atom have the right number of bonds? Hydrogens can only make one bond. There we go. So the hydrogens are good. Bromine can only make one bond. Nitrogen is in group 5, should make 3 bonds, 1, 2, 3. Oxygen is in group 6A, should make 2 bonds. And remember, a double bond counts as 2 bonds. Right? Double bond counts as 2 bonds. So the oxygen is okay. And this oxygen here is making 2 bonds. And finally, the carbons. They should make 4 bonds. 1, 2, 3, 4 for this carbon, and 1, 2, 3, 4. Again, the double bond counts as 2 bonds. So we can feel reasonably comfortable that this structure is correct. Right? That this structure is correct. Now, how about our functional groups? Well, right here is our amine group. Right? So we're going to write amine there. And over here is our good buddy, carboxylic acid. Carboxylic acid. And again, if you take organic chemistry or biochemistry, you're going to see tons of amine groups and carboxylic acid groups. Tons of them. I mean, they show up in proteins. Proteins are made out of amino acids. Okay? Any question or comment? Any question or comment? Again, notice how recognizing the functional groups at the beginning helped us to make this structure, right? Helped us to make this structure. So when you're doing these, you should have that functional group listing also up on the screen. Question or comment there, somebody have? No. Okay, so again, you should have that functional group listing there. You might want to write them on a sheet of paper. It'll only take you 2 minutes to write them out. Okay, so no question or comment. I'm going to erase this and we'll move on to the next one. All right, let's bring it up. All right, I already have it. So you can see we're starting to get bigger molecules here. So we have HO, CH2,
OCH,
O, CH,
CIN,
CL. Actually, I have it right here. CL, NHBr. NHBr. Okay? So, functional groups. What functional groups do we have? Well, there's no carboxylic acid because carboxylic acid has 2 oxygens in it. What's this here?
alcohol,
That's an alcohol. Remember, we have 6 functional groups. 5 of them have an oxygen atom. Only 1 of them has a nitrogen, but it's NH2. This is not an amine group. Now here's an oxygen. What's that? What functional group might that be?
ketone,
No, it's not going to be a ketone. We'll see. We'll see. All right, but we should be aware that this is probably going to be a functional group. We're just not sure right now. This is almost certainly an alcohol. There's our good friend, the CH2. So I'm going to put that CH2. And there's the alcohol. So that brings me to there. All right, and an open-ended bond on the carbon. An open-ended bond on the carbon. All right, so now I'm going to put the oxygen with an open-ended bond. With an open-ended bond. And then we have CHCl. Again, chlorine is a halogen. It can only make 1 bond. So this is going to be very similar to the last problem where we had a bromine here. So this, since chlorine can only make one bond, the CHCl is going to look just like CH2. Right? Does everybody understand that? And again, it's because the chlorine can only make one bond. So I'm going to put the carbon, let's put the hydrogen down below this time, just for the sake of being a little different. And that's going to take us to the chlorine. All right? Again, an open-ended bond to keep the growing chain going. Okay? And then finally, we have NHBr. Bromine can only make one bond. So this is going to look just like NH2. It's going to look just like NH2 because bromine can only make one bond. Well, I know what NH2 looks like. There we go. There we go. Okay, so before we do the functional groups, let's check and make sure that every atom obeys the octet rule. In other words, every atom has the proper number of bonds. So each hydrogen should have one bond. One bond, one bond, one bond, one bond, one bond. So the hydrogens are okay. How about the oxygens? 2 bonds here, 2 bonds there. So that's good. The bromine is a halogen, 1 bond. The nitrogen is a Roman numeral group 5A, should make 3 bonds, which it does. The chlorine should only have 1 bond. Well, I forgot about the chlorine. Now, how about the carbons? 4 bonds. 1, 2, 3, 4, and 1, 2, 3, 4. So this structure, I can feel very confident is correct. Right? Very confident that this is correct. Okay, so this was in fact the alcohol that we thought it was at the beginning. So I'm going to circle that and write alcohol. So what functional group did that turn out to be?
Ether.
Yes, very good. This is in ether. In ether. All right. Okay. And that's not an amine group. It has the same structure as an amine group, but the bromine took the place of one of the hydrogens, so it's no longer an amine group. Okay, any question here? So if you take organic chemistry, you'll learn how to give a name to a beast like this. Right? Any question or comment? All right.
Does it matter if you end with the Br or the H?
Say again?
Does it matter if you end with the bromine or the hydrogen at the end?
No. No, it does not. The reason for that, and again, this is why I wanted us to do the dry lab with the models, where you could make these. Any single bond you can spin around, right? You can spin around it, okay? You cannot spin around a double or a triple bond, however. You cannot do that. Actually, I have my models. Oh, wait. They're out in my car. Actually, we could have built one of these. We could have built this and we could have seen that. Actually, maybe later on I can run out and grab them. I'm pretty sure I didn't bring them to my storage locker. I might have. Wait, let me see if they're here. I don't see them here. Yeah, they're not here. Okay. But again, because you can spin around this, so I can spin around this bond right here. If I spin 180 degrees, that brings this bromine up top. Right? I can spin around this bond, that brings the chlorine to the bottom. Okay, so that's why it doesn't really matter. Again, for double and triple bond, it does matter. All right, any other question or comment? Okay, let's move on to the next one here. I don't know if I can pause the recording and come back to it. Okay, so let's take a look at the next one here. So H2CF CH, this is going to be a good one. OHCH.
Mr. Raymond,
Yes.
you skipped one.
Oh,
I
okay.
have
All right, we'll come back to that one since I already have this one up.
Okay.
All right, thank you. We'll come back to that one. Okay. Now, we know what CH2 looks like. Well, first off, we should ask, do we have any functional groups? And it looks like that's probably an alcohol. Okay, that looks like that's probably an alcohol. All right. Now, I don't see any CH2. Oh, actually, there's one here. Okay, and there's actually a CH2 here. Now, let's start drawing. All right, so CH2, I know what that looks like. All right, and then bonded to fluorine. So I need a third bond to the carbon, and then an open-ended bond takes me onto the next group in the growing chain. All right, now, I just want to stop here for a moment, and quite often, you'll see this, CH3. Now, CH3 can only make one bond. So quite often, you'll see this terminating or beginning a molecule. It can also be top or bottom because it can make one bond. Remember, anything that makes one bond, like a carboxylic acid, an amine group, and alcohol, if it's in the middle, it must go top or bottom because it can only make one bond. Right? For it to be in the middle of the molecule, it has to grow on both sides. Right? But if you're only making one bond, you can't do that. So it would have to be top or bottom, or the extreme left, or the end of the molecule. Right? So this H2CF looks just like CH3. Right? So we'll put the fluorine here. And again, it doesn't matter where the fluorine is at, because you can spin around this bond and change positions. Now here I have CHOH, right? And if you remember what I just said a moment ago, an alcohol can only make one bond, right? Because oxygen makes two bonds. One of them is taken up by this alcohol hydrogen atom. So it can only make one other bond. If it can only make one other bond, it's got to go top or bottom. Top or bottom. It cannot be, the oxygen cannot be part of the growing chain. Well, if it's going to go top or bottom, then this CHOH is going to look just like CH2. It's going to look just like CH2. All right? And again, that's because the alcohol group can only make one more bond. So let's put that in there. CH, all right? So that brings me to here. And then the OH. I can't put the OH here. Don't write this. I can't put the OH here because then I'm done. All right? We could grow it down, but we want to grow it left to right. All right? So I'm going to put the OH down here. Right? And then our force bond for the carbon is going to extend the chain. So that puts me to there. Right? That puts me to there. Okay, does everybody understand that? Why the alcohol has to be top or bottom. Okay? Now, here we have CH2F. Fluorine, just same as over here, fluorine can only make one bond. Right? So it's going to look just like a hydrogen when we draw it out here. Okay, so this CH2F is going to look just like CH3. So I'm going to put a carbon, and then a hydrogen, and a fluorine. And we're done. We're done. Okay? Let me make that carbon look more like a C there. Okay. All right. Now, we're going to go back and make sure every atom has the right number of bonds. Hydrogen should have 1, 1, 1, 1, 1, 1. So we're good there. The fluorine should only have 1. The oxygen should have 2. And each carbon should have 4. So 1, 2, 3, 4. And then this carbon. 1, 2, 3, 4. And then this carbon. 1, 2, 3, 4. Right? So we're good. Now, functional group. Well, there's only one. There's only one right here is an alcohol. An alcohol. Okay? Any question or comment? And again, I could spin around this bond and take the OH up to the top and take this hydrogen down to the bottom. Okay? We should understand that these are actually three-dimensional molecules, though. That was another thing I was hoping that you could see for yourself with the models. Because we draw them on flat paper here, and you start to think, well, they're flat, just like a sheet of paper, two-dimensional, but they're not. They're actually three-dimensional objects. Okay, but you don't see that drawing them on a piece of paper here. Okay, so let's back up and do that one that I missed. All right. So that was HCF, CL, CN. Okay. Do we have any functional groups? Well, none from our list. Okay, there's no oxygens, so none of those. And the only other functional group we have that doesn't have an oxygen is the amine group, NH2, and I don't see that anywhere here. So none of our functional groups are present. Okay, well, where are we going to begin? Well, let's see. This can only make one bond. That can only make one bond. That can only make one bond. So let's put that in. I'm going to start with that carbon. Here's this hydrogen, this fluorine, and this chlorine. And the fourth bond, the open-ended bond. Okay? The open-ended bond. Right? Then we're going to put this carbon atom in. That takes me to there. All right? And then the nitrogen. All right? That takes me to there. Now, we have a problem here. This carbon only has two bonds. This nitrogen only has one bond. All right? So we don't have any more atoms to put in. So I'm going to have to put a multiple bond here. So let's make it a double bond. Okay, now this carbon has 1, 2, 3 bonds. This nitrogen has 2 bonds. Still need one. Each atom still needs one more bond. I'm going to make that a triple bond. A triple bond. Okay? Now, let's go back and check. All right, does everything obey the octet rule? Hydrogen should make one bond. Fluorine should make one bond. Halogen, chlorine is a halogen, makes one bond. Nitrogen should make 3 bonds. This triple bond counts as 3 bonds. Counts as 3 bonds. Okay, and then 4 bonds for the 2 carbons. 1, 2, 3, 4 for the left carbon, and 1, 2, 3, 4 for the right carbon. This structure is correct, and we have no functional groups. No functional groups. So this is the first one. Well, actually, we had the one with the carboxylic acid that had a bond order 2 in it. Okay, but again, I can rotate around that bond, rotate around that bond, rotate around that bond. It can spin like crazy. Rotate about that bond. You cannot rotate around that bond. You cannot rotate around. Okay. Any questions or comments? Any questions or comments? Okay. Hopefully we're going to see some other ones in the, so this one, SiO2. Okay, now, let's see, silicon is in group 4. It's in group 4. So, it's going to have to make 4 bonds. Each oxygen makes 2 bonds. Now, we also have a unique atom. Now, generally, we don't worry about unique atoms here, but because usually when we're making structural formulas, it's a much bigger molecule than this. Okay, but I mean, we do have a unique atom here, silicon. So I'm going to put that in the middle. Right, and then an oxygen on either end. Right, an oxygen on either end. Now, do the atoms obey the octet rule? Well, let's see. Oxygen should make 2 bonds. So I need to put a double bond there and a double bond there. All right, so this oxygen's happy, that oxygen's happy. Silicon has to make 4 bonds. It's a Roman numeral group 4A. So 2 bonds there, 2 bonds there. This is correct. Right, that is correct. Okay, and I think that's the end of that particular assignment, right? That's the end of that one. Any questions or comments? No functional groups. Any questions or comments? Okay, then we'll tackle the second one. And hopefully, let me look through this one real quick. Right. Well, we'll probably have time to do a few extra ones at the end. Okay. So now we're on to structural formulas 002. 002. And the first one is HSF. Okay? Now, I notice the hydrogen and the fluorine can only make one bond each, so they have to be on the ends. The sulfur is in the middle, the fluorine and the hydrogen on the end, and we're done that fast. Sulfur has to make two bonds, which it's making. Hydrogen makes one, fluorine makes one. This structure is correct. That structure is correct. Okay, that was a pretty easy one. Okay, all right, let's look at the next one. Okay. So, again, fluorine can only make one bond, so this is going to look like CH2. The alcohol group, I have an alcohol there, that can only make one bond, so CHOH is going to look like CH2. All right? So let's go ahead and start over here. Again, this is going to look like CH2. So I'm going to put the hydrogen up top, the fluorine on the bottom. Extend the chain. Right? I have no atom to put over here. And that takes us to there. All right? Now we're going to put the CHOH in. That's going to look just like CH2. All right? So we know what that looks like. Okay? All right, now we're at the end of the molecule. And we don't have any other atoms to put in. Okay, but we see here, hydrogen makes one bond. Fluorine makes one bond, it's okay. The hydrogen down here is, well, here, let's draw that. I kind of put it off to the side because I wanted to make sure everybody could see it. That hydrogen makes one bond and this oxygen makes two bonds. But there's a problem with the carbons here. Carbon should make four bonds. This one makes 1, 2, 3, and the one on the right makes 1, 2, 3. So what do we need to do?
The one in the middle becomes a double bond.
One in the middle, double bond, bond order 2. Very good. Double bond. Okay? So now everything has the proper number of bonds. We just checked it a moment ago, and we made the correction for the two carbons. Okay? Now, do we have any functional groups? And the answer to that is yes, we do. We have our alcohol here. We have our alcohol group here. Okay? Now, I should remember we said you cannot rotate around a double bond, right? Now, I'm not going to hold you responsible for this, but since this is going out on YouTube, I don't want people saying, oh, what the heck's that guy teaching? We should be aware that since you cannot spin around this bond, there's another molecule that looks like this. Actually, these are more, these should be 120 degrees, make the people on YouTube happy. Fluorine, double bond, COH. Okay, so you see the difference here. In this one, the alcohol and the fluorine are on the same side of the molecule. In this one, the fluorine and the alcohol are on opposite sides of the molecule. These are two completely different compounds. Now, I'm not going to ask you to worry about that. This is just introductory chemistry. You'll worry about that when you take organic chemistry, okay? Or general chemistry. But I just want you to be aware that this situation does exist. And again, it's due solely to the fact that you cannot spin around a bond order 2. Okay? And again, if we were making the models, you would see why that is. But unfortunately, you can't. Okay? When I say these would have different, these are different compounds, everything about them is different. They're going to have different boiling points, different melting points, different indices of refraction. Their spectra will be different. All right? But for our purposes, if you give either one, it's correct. All right? We're not going to worry about this right now. All right? It's beyond what we're trying to do. All right? Any questions here? Any questions? All right. All right, let's look at the next one. Okay, well, I see some oxygens here. What functional group is that?
Carboxylic acid.
Right, carboxylic acid, and that's it. No other functional groups. Now I see CH2. I know what that's going to look like. I see CH2 here. I know what that's going to look like. So let's begin here. CH2, and then this fluorine has to be bonded to that carbon. Okay, so that brings me to there. That brings me to there. Okay, now I have a CH2. I know what that looks like. Open-ended bond. And then this CO2H, because we have that functional group listing in front of us, we know what the carboxylic acid group looks like. C double bond O, O, H. And that brings us to the end of the molecule. All right? Again, you're wise to check off up on top here. Okay? Now, let's go back and make sure every atom has the proper number of bonds. Halogen should have 1 bond. Hydrogen should have 1 bond each. The oxygen should have 2 bonds. Double bond counts as 2. All right, 2 bonds here on this oxygen, 2 single bonds. And each carbon should have 4. 1, 2, 3, 4 for this carbon and this carbon. 1, 2, 3, 4, and this carbon. 1, 2, 3, 4. All right, so this structure is correct. And let's draw our functional group, or circle our functional group. Now, we don't call this a carboxylic acid and an alcohol, or a ketone and an alcohol, right? An atom could only be part of one functional group. One functional group. So we're going to call this our carboxylic acid. Right, there we go. There we go. Okay. And that's it for that one. Let's see for the next one. Again, anybody got a question or comment, speak up. Okay. This is no question. We'll move on to the next one. All right, so let's write them out. H2N, CH, COH, CH2, CHO. All right, so we got a couple oxygen atoms in there. All right, and we have a nitrogen here. Is this an amine group?
Yeah,
No,
it's
yes,
just a
it is.
different format.
NH2. What's this going to be here? This oxygen.
Aldehyde
Aldehyde? Yeah.
or ether.
Well, we'll see. We know it's probably going to be some functional group. Here, look at that. What's that?
Alcohol.
Alcohol. And how about this at the end? Well, there's HO. What's this going to be?
Aldehyde.
What's that going to be? Somebody said?
Aldehyde.
Aldehyde. You got to be careful with aldehydes. Remember, aldehyde can only make one bond. So we definitely have an amine here, probably an alcohol, and maybe an aldehyde there. All right, we'll have to draw it out and see. All right, so here's my amine group. Open-ended bond on the nitrogen. Open-ended bond on the nitrogen. All right, now here I have just CH and then another carbon. So that brings me to there. Then another carbon. Okay, now here I have COH. Now, don't draw this yet. All right, so what if I put this carbon, and what if I think that's a ketone and put it up there? Then I have a hydrogen next. I'm done. I have nowhere to put the rest of this. So this cannot be like a ketone or an aldehyde. It cannot be. That tells us this does have to be the alcohol group. Right? It does have to be the alcohol group. So let's put the alcohol in, the carbon, and then the alcohol, OH. That brings us to here, open-ended bond. Open-ended bond.
Can you give a minute to copy that?
Okay.
I was asking him to give me a minute to copy that.
We good?
Yes.
Okay. So next we have CH2. We know what that looks like. Better by now. That's in a lot of these molecules. All right. Open-ended bond. That brings us to here. Now we have this last little functional group here. Okay. Well, let's see. Again, don't draw this on there. Well, it can't be like, well, can it be like that? Well, where am I going to put the oxygen? I can't put the oxygen there because hydrogen can only make one bond. So can it be an alcohol? No, it can't, because then there's no fourth bond, third or fourth bond for this carbon. So it can't be that. There's only one thing left. A carbon with a double bond to the oxygen and a hydrogen, an aldehyde group. An aldehyde group. Well, let me check my phone here. Hello? Yes. Who is this? Aldo, can I call you back? I'm actually in the middle of a Zoom class for my college class. Can I call you back in like a half hour? Okay, I'll call you right back. Okay. All right. High school student not turning in any work. I got to call back. Okay, sorry about that. So, functional groups. Here's our amine group. Okay, here's our alcohol group. And down here is our aldehyde group.
Would you need a double bond between the first two carbons?
Oh, yes, thank you. You know, that's one thing we forgot to do. That phone call distracted me. We never checked to make sure that every atom had the right number of bonds. So let's go back and do that. Okay? Each hydrogen should have one bond, one bond, one bond, one bond, one, one, one. The oxygen should have two bonds and a double bond there for that oxygen. The nitrogen should have three, and the carbon should have four, 1, 2, 3. And this carbon only has 1, 2, 3. So as whoever said that, yes, we need bond order 2 there. And then this carbon has now 2, 3, 4, and this carbon has 1, 2, 3, 4, and this carbon has 1, 2, 3, 4. So we're good. We're good. Thanks for catching that. Okay, a phone call threw me off. All right. Any question here? Any question? Again, if you're smart, you'll do these like in pencil, or because you know you might have to do some erasing when you're doing this for the first time, right? This really is an art to doing this. It really is. Any other questions or comments? Any other questions or comments? All right, we'll move on to the next one. Oh, it's getting hot in here. We're only not even to the middle of May yet. So CH3, we know what that looks like. CHF, we know what that looks like. OO, we don't know what that looks like. And CH2, we know what that looks like with a BR in for good measure at the end. Okay? All right. Now, we have 2 oxygens here. The only functional group we have with 2 oxygens is our carboxylic acid, but that doesn't look like a carboxylic acid, right? Could it be like 2 alcohols back to back, or we'll just draw it and see. All right, now, CH3, we know what that looks like. Carbon with 3 hydrogens attached to it. 1, 2, 3, and then an open-ended 4th bond for the carbon. Okay, now CHF, again, the fluorine can only make 1 bond, so this is going to look just like CH2. And again, it doesn't matter whether I put the fluorine on the top or the bottom. Open-ended bond here to keep the chain growing. All right, then I'm going to put the first oxygen in with an open-ended bond. I'm going to put the second oxygen in with an open-ended bond. Okay, and then a CH2 group. We know what that looks like. And then a bromine. Okay, then a bromine. Now, before I forget, let's check that every atom obeys the octet rule. In other words, has the proper number of bonds. The halogens should each have 1 bond, which they do. The hydrogens should each have 1 bond, which they do. The oxygen should have 2 bonds, which they do. And the carbon should have 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4 for this carbon, and 1, 2, 3, 4 for this carbon. Okay? Now, this is not any of our functional groups. This is a functional group. If I remember correctly, this is an anhydride, but it's not as common as the functional groups I gave you on that list. Right? I mean, there's hundreds of functional groups. I only gave you the most common ones on that list. Okay? All right, so this is not one of our functional groups. We don't need to circle it. Okay, so we're done with this one. Again, we could spin around any of these single bonds. We can spin around any of them. Okay. Any question or comment? All right.
Are those 2 oxygen not ether because there's 2 of them?
Say again?
For the oxygens, is it not the ether functional group because there's 2 of them?
Yes, exactly. Exactly. For it to be an ether, you usually have a carbon on either side. So in those functional groups that I gave you, the open-ended bond is always, that next atom should be a carbon atom, right? Should be a carbon atom.
Okay.
Okay? Yeah, I guess I did. I mentioned that earlier, but I know I didn't emphasize it. That's why I like in water. All right, in water we have this. That's not considered to be an alcohol, right? Because over here, this is not a carbon atom. The same thing, the hydrogen peroxide, I think the second one we did. All right, and this, all right, carbon dioxide. Well, I have a unique atom. So let's put that in the middle. Then I have an oxygen here and an oxygen here. All right, now oxygen needs to make 2 bonds, so carbon needs to make 4. There we go, we're done. We're done. These are not considered to be ketones. All right, those are not ketones. Okay, so there's carbon dioxide. All right, no functional groups. Okay. All right. And again, you could not spin around either of those 2 bonds. All right, so let's look at the next one. Okay. So let's start drawing. I see no functional groups, there's no oxygens, and there's no nitrogen, so none of our functional groups are here. All right? Now, I know what CH3 looks like, so let's go ahead and draw that. It's just CH2 with a 3rd hydrogen attached to it. Then we have the open-ended bond to grow the chain. Then I'm going to put a carbon with a hydrogen. Now, notice I don't put the hydrogen there because we want to grow the chain across the paper. Right, so I'm going to put an open-ended bond there. Right, and then we're going to have a sulfur. Then we're going to have a sulfur. Okay, now, let's see. Does every atom obey the octet? Each hydrogen has 1 bond. Sulfur should make 2 bonds. So I'm going to put a double bond there. Sulfur should make 2 bonds. Now it does. And each carbon should make 4. 1, 2, 3, 4. So 4 on the left carbon and 1, 2, 3, 4 on the right carbon. All right? So there we go. There's our molecule. No functional groups. Remember, I could spin around this bond like crazy, but I cannot spin around this one. Cannot spin around that one. Okay? Any questions or comments? Any questions or comments? All right, so we'll do the last one on here, and then I'm going to throw a couple other ones in for good measure. I want to take a look at the one you're going to turn in, because I think we may need a bit more practice on some of the types that might be on there. Okay. Well, let's see. I see an OH here. So maybe an alcohol. I see 2 nitrogens, but they're not NH2. They're not NH2. Now, actually, this brings up about something that we talked about last class when we went over the rules for drawing structural formulas. All right, and we said never move an atom across a non-hydrogen atom unless you have no other choice. So in other words, when I'm drawing this, I don't want to move this hydrogen across the oxygen and give it to this nitrogen, making this an amine group. If I had meant for this to be an amine group, I would have just written H2N here. I would have just written H2N. Why would I split the hydrogens up? Right? So you never move an atom across a non-hydrogen atom unless you have no other choice. Sometimes you just have no other choice. That's some of the examples I want to do. Okay? So this hydrogen is going to go with this oxygen, not with this nitrogen. Does everybody understand that? Do I need to say it again? All right. Never move an atom across a non-hydrogen unless you have no other choice. All right, so HN, I know what that looks like. Okay, nitrogen is going to be part of the growing chain here, but it needs another bond, a 3rd bond. So this OH can only make 1 bond, and I don't want it to be part of the growing chain because whatever atom is going to go here has to make 2 bonds. Right, so I'm going to put the OH down here or up top, it doesn't matter. That brings me to here. That brings me to there. All right, now, the next atom is a nitrogen, which can make a bond on both ends. There's a hydrogen here. The hydrogen cannot go here, so I'm going to put the hydrogen there. That brings me to there. That brings me to there. Okay, then we have CH2. Well, hey, we know what that looks like. And then a bromine. And we're done. But as always, we're going to go back and check, make sure every atom has the proper number of bonds. Each hydrogen should have one, which they do. The halogen, bromine, should have one, which it does. The oxygen should have two. The nitrogen should have three. 1, 2, 3, 1, 2, 3. Right? And the carbon should have 4. 1, 2, 3, 4. So this is correct. Right? This is correct. Now, whether or not you wanted to call this an alcohol, I generally would not. My forte is not organic chemistry. But like I said, to make it easy on ourselves, I said a few problems ago, that when you look at that functional group listing, that the open-ended bond should always be to a carbon, right? So we won't call this, we will not call this an alcohol group. We won't. But if you circle it and call it an alcohol, I won't mark it wrong, right? I won't mark it wrong. But if you do it in water or hydrogen peroxide, I am going to mark it wrong there. Okay, any questions or comments? Any questions or comments? All right, so we got about 15 minutes left. That finishes both of these assignments. I want to do a few more, especially with this moving atoms across non-hydrogen atom business. Now, be patient with me because I'm doing these off the top of my head. Let me just have a quick look at the third one, which you're going to actually turn in. Oh, I'm hitting the wrong key there. There we go. All right, I think it should be okay. All right, let's take a look at some here. Now again, I might make some mistakes here. I'm just making these off the top of my head. Let's look at that's a 3. Let's see here. I'm going to make this a real hard one. All right. So this is going to be kind of everything together. Everything together. All right. So here, this kind of looks like an, we'll let you copy that down first. Okay. All right. Now here's probably an amine group. All right, there's another amine group. I have an OH group here, so that's going to be like either a COH. That's either going to be like an alcohol or an aldehyde. And then I got the same thing out here. This is going to be either an alcohol or an aldehyde. All right, so let's draw it out. Now, with some experience, you can look at it and know if those are going to be alcohols or aldehydes. But we'll draw it and decide, and then I'll point that out at the end. And hopefully I didn't screw up here. All right. Okay. So NH2, we know that's an amine group. Check off there. Now, we have a open-ended bond here for the third bond on the nitrogen, and that's going to bond to the carbon. And the carbon is bonded to a hydrogen, which I know has to go up top. Now, pay attention here. Here I have CH3, right? So that carbon is already bonded to 3 hydrogens. It can only make one more bond. So I can't put it here. Just remember, I want to grow the chain this way, right? Do every problem the same way, right? I mean, I could conceivably grow the chain down this way, but I want you to get comfortable doing all of them the same way. So since that CH3 can only make one more bond, I'm going to put it down here. And then an open-ended bond on this carbon for the 4th one, right? For the 4th one. All right, now I have another carbon, brings me to there, and now an OH. I don't want to put the OH here because that ends the chain. So I'm going to put it up here. Let's put it on the bottom here. I'm going to make this bond a little bit longer. So carbon OH. That brings me to there. All right, now I have an open-ended bond here. Now here I have, I'm going to slow down to give you a chance to copy things down. Okay, so here I have an NH2 group, right? NH2. I don't want to put it here because that ends the chain. And the amine group only has one open-ended bond. If I put it here, the chain stops growing left to right. All right, so I'm going to put it, well, let's see. I still have a bond up here to make on this carbon. So I'm going to put that amine group up here. All right, and seemingly I have violated this thing that I was just saying, do not move atoms across non-hydrogen atoms. I took this nitrogen and moved it across this oxygen to bond it to this carbon, right? But remember, there's a corollary there. Do not move atoms across non-hydrogen atoms unless you have no other choice. I have no other choice. I have to move this nitrogen to bond to this carbon. I have no other choice, right? If you have another choice, then don't do it, right? So there we are, right? Does everybody understand that? Again, if I put this here, I stop growing the chain, so I put it up top. And even if I do put it here, that's still moving the nitrogen across the oxygen to bond directly to the preceding carbon atom. Right? Now I have this carbon atom, and let's see, we said this was going to be some functional group out here. Well, we said either an alcohol or an aldehyde. So let's try an alcohol first. COH. Well, that's no good. That's not going to work. All right? Because this carbon is short 2 bonds. So it's not an alcohol. So let's try the aldehyde. Let's try the aldehyde. Carbon, double bond OH. That makes more sense. That makes more sense. Because now this carbon has 4 bonds. Right? That carbon has 4 bonds. Now, let's go back, and I'll point out to you towards the end how I knew at the beginning this was an alcohol and this was an aldehyde. All right? So let's see. Does everything have the right number of bonds? Hydrogen should have 1, 1, 1, 1, 1, 1, 1, 1, 1. So the hydrogens are good. The oxygen should have 2 bonds there and 2 bonds there. The nitrogen should have 3. They do. And each carbon should have 4. 1, 2, 3, 4 on this carbon. 1, 2, 3, 4 on this carbon. 1, 2, 3, 4 on this carbon. And 1, 2, 3, 4 on this carbon. So we are good. We are good. Okay. How about functional groups? Well, let's take a look. Here's an amine group. Here's an amine group. And over here is a second amine group. And this guy down here is not a ketone, but an aldehyde. Remember, a ketone has two carbon atoms on either side here, two open-ended bonds to carbon atoms, but an aldehyde, one of them is a hydrogen and then a carbon on the other side. So here is the aldehyde. The aldehyde. Okay, and we have an alcohol here. A lot of functional groups in this one. All right. Now, I don't know if you could ever make this molecule. This oxygen would be pretty positive, but we're not worried about that. We're just want to draw them. Okay? We're not trying to actually make them. All right, so there's that guy. Any questions or comments there? Any questions or comments? All right, I'm going to do one more then. One more. That'll bring us up. All right, no question or comment before I erase this. Oh, I was going to say how I knew by looking at this that this was an alcohol and this was an aldehyde. If I wanted this to be an alcohol over here, I would have written this COH, because then the oxygen would be directly bonded to the carbon. Here, let's write it up here in red. COH. Then the oxygen is bonded to the carbon and the hydrogen is bonded to the oxygen. So when you see it written like that, with the hydrogen between the carbon and the oxygen, that kind of tells you that's an aldehyde and not an alcohol. Same thing here. Here I have the oxygen directly coming right after the carbon and the hydrogen coming right after the oxygen. That kind of tells me this is probably going to be an alcohol, right? So that's how you can, again, with experience, you'll be able to pick this up. Okay? All right, let's try one more then. And amazingly, I didn't screw that up for just making it off the top of my head. Usually I do. All right, let's try one more here. Let's see what we have. Okay, we'll give you a chance to copy that down. And I think I maybe screwed up right here. I think I need another atom in there. Yeah, I need another atom in here. Sorry about that. Oh, wait, no, I did. No, I didn't. No, I didn't. No, I didn't. Okay. All right, everybody have that? Everybody's good? We can get started? All right, so we should have a couple functional groups. There's definitely an amine group there. Definitely an amine group. Out here is almost certainly an alcohol. And out here is here's a carboxylic acid in the middle of the molecule. Sorry, we should say in the middle of the molecular formula. And out here is either an alcohol or an aldehyde. Right? And on the basis of what I just said at the end of the last one, this is probably going to be an aldehyde because the hydrogen is next to the carbon. If I wanted this to be an alcohol, I would have written HOC. HOC. Okay, now, what else can we deduce from this before we even begin drawing it? Well, I know that the amine group can only make one more bond. It only has one open-ended bond, so it's got to be top or bottom. Top or bottom. Same with this carboxylic acid group, CO2H. Okay, CO2H only has one open-ended bond off of the carbon. So it has to be top or bottom also, because it can only make one bond. It can only make one bond. Okay, so let's start drawing this. Well, let's begin with the carbon here. And let's see. If I want this to be an alcohol, don't write this down, all right? And then bond it to the next carbon. This is going to be short a bond here. So this cannot be an alcohol. It must be an aldehyde. It must be an aldehyde. So let's make it an aldehyde. C double bond O, H, that takes me to there, and an open-ended bond. An open-ended bond. I'm going to make it a long bond. We're going to need some room on this next one. Okay? I'm going to put this next carbon in now. That takes me to there. Now, again, we said carboxylic acid group, CO2H, can only make one bond. So I don't want to put that here. I'm going to put it top or bottom. I'm going to put it down on the bottom. C, double bond O, O, H. All right, so there's my carboxylic acid group. There's my carboxylic acid group. Okay, so now I have the amine group, which again only has one open-ended bond. It can't go here because that ends the molecule left to right. We could grow it up here, but again, we want to do them all the same, grow it left to right. So I'm going to put that NH2 group up here. That brings me to there, and an open-ended bond. An open-ended bond. Okay? I do see one mistake there at the end. Okay, now, next is CH2. We know what that looks like. Open-ended bond. Now, okay, so now this carbon, and then a hydrogen, all right? And then this has to be an alcohol, because don't write this. If I make that an aldehyde like that, this carbon now has 5 bonds. It now has 5 bonds, which it cannot have. But I did screw up one little mistake here. All right, if I put the alcohol in here, now this carbon is short a bond. This should actually be CH2OH. So please make that correction, CH2OH. Okay, I'm actually surprised I didn't make more mistakes than that. Okay, CH2OH. Everybody draw this? So let's check the number of bonds. Each hydrogen with 1. 1, 1, 1 and 1, 1, 1, 1, 1, 1. Amazing how many people will turn in assignment with hydrogen with 2 bonds or even 3 bonds. Each oxygen should have 2. Double bond is 2. There's 2 there, and there's 2 there. So the oxygens are good. The nitrogen should have 3 bonds. 1, 2, 3. So it is good. And the carbon should have 4. 1, 2, 3, 4 on this carbon. And for this carbon, 1, 2, 3, 4. So that's good. This carbon, 1, 2, 3, 4. So that's good. This carbon, 1, 2, 3, 4. That's good. This carbon, 1, 2, 3, 4. That's good. We're good. We're good. And again, always go back and check. You did all this work. You see, it doesn't take very long to check. It doesn't take very long to check. And by now, you should recognize oxygen's got to make 2, carbon 4, and nitrogen 3. I mean, you should, and the halogen's 1. Okay, so what about functional groups? Well, let's see. I see an amine group here. I see an alcohol here. I see an aldehyde here, not a ketone. We never did one with a ketone. And down here, I have the carboxylic acid. I'm just going to write acid. It's carboxylic acid. Let me just do one more with a ketone, because we didn't do one with that. I want you to at least see one with a ketone. All right, we'll make it a simple molecule. Again, an atom can only be part of one functional group. Okay? Usually when you're going to move like an atom across another non-hydrogen atom, it's going to be like a functional group you're going to be moving. But not always, not always. Any questions or comments here? Any questions or comments? All right, we'll erase this and I'll do one more, make sure we have a ketone in it. So you see, the carboxylic acid in the molecular formula doesn't have to be on the ends. The same with an amine group. It can be written in the middle of the molecular formula, but that just means it's going to go top or bottom. All right, so let's look at one that has a ketone in it. Ketone. Let's see if I can do this without screwing it up. Okay. I said I was going to make it easy, but I'll give you a chance to write that down. Again, I don't know how hard these molecules would be to make, but we're not concerned with that. Some organic chemists may say, oh, you're crazy. That would be, you could never make that molecule, but we don't care about that. We just want to see if we can draw them. Okay, so here's an amine group, and it's in the middle of the molecular formula. So I know it's going to be top or bottom, top or bottom. Right over here, almost certainly an alcohol group. And here is probably our ketone. So at least 3 functional groups here. So let's begin. CH3, we know what that looks like. An open-ended functional group, or open-ended bond, I mean. Right now, CHNH2, again, the NH2 can only make one bond. So it's going to go top or bottom. So this CHNH2 is going to look just like CH2. So I'll put C with an H up on top and the amine group on the bottom in an open-ended bond. An open-ended bond. Okay? Now, I take a look here, and I'm going to look a little bit further ahead. Here I see a CH2. That almost certainly is going to be bonded to this carbon. So that means this oxygen has to be up top or down below. Right? So I'm to there, and then the CH2. Open-ended bond. Right? Now, I can already see this carbon only has 3 bonds. This oxygen only has 1. So I'm going to make that a double bond, and there's our ketone. There's our ketone. Right? We could have saved that till the end, but we see it now. Why not put it in now? Right? So CH2. Then we're off to the next carbon atom with a hydrogen attached to it. right? That brings us to here. And then another carbon atom with another hydrogen attached to it, and then an alcohol group. And we're done. All right, now let's check and count bonds around each atom. Make sure they obey the octet rule. All the hydrogens should have one. One, 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 one. So we're good there. The oxygen should have 2 bonds and 2 bonds. We're good there. The nitrogen should have 3. 1, 2, 3. So we're good there. And each carbon should have 4. 1, 2, 3, 4 on this carbon. On this carbon, 1, 2, 3, 4. So we're good there. This carbon, 1, 2, 3, 4. So we're good there. This carbon, 1, 2. Guess I forgot to draw a line there, huh? 1, 2, 3, 4. So we're good there. Ooh, what's going on here? This carbon only has 3, and this carbon only has 3. So again, that's a good indication. When you have 2 atoms next to each other, they're usually going to be carbon atoms that each need 1 or more bonds, 1 or 2 more bonds. That's an indication you need a double or a triple bond. I didn't draw any with a triple bond. Actually, we did one on the first one, the first assignment. All right, so now this carbon, 1, 2, 3, 4, and this carbon, 1, 2, 3, 4. We're done. We're done. All we got to do is put the functional groups in. You see how important it is to go back and check. We would have missed that this is a double bond. We would have missed that. These are either right or wrong. They're either right or wrong, right? No partial credit on these guys. All right, just same with the Lewis structures. All right, so let's do the functional groups. So here's my amine group. Here's my ketone. All right, and here's my alcohol group. There's my alcohol group. Okay. All right, I'm about talked out. Any questions or comments? Any questions or comments?
What are we going to do for lab?
Well, you must have checked in a little late. I said I tried to find a dry lab for us. I didn't have success at that, so we're not going to do lab tonight. Okay?
Okay.